purpose of this video is to share some of the work that I was doing at Pearson as an assessment specialist and AI ambassador. So I collaborated with Massachusetts educators and Concord Consortium, which is a company that creates science-oriented computer simulations, kind of like PhET Physics, if you're familiar with that website, to design and implement the innovative science assessment for grades 5 and 8, including interactive computer simulations that align with real-world phenomena. So what does that mean? It's a bullet point, blah, blah, blah. If you come down here on my LinkedIn tutorial, you can see a PDF version of what this innovative science assessment looks like. This is one released 8th grade test from 2022. But I can show you the computer one too. So if we go to the Massachusetts Innovative Science Resource Center, all right, and you'll see there's sample tasks. There's all this stuff, Pearson accessed, administration. This is for teachers, and this is for teachers and students to prepare the students for the test. So we have sample tasks. So you could see we have our released exams, 2022 and 2021. And if you click on the 8th grade or 5th grade, you'll see that there's the computer-based one, and then there's also the paper sample. So, obviously, whenever you create a statewide assessment, you have to have paper copies too, because not all students have access or the ability to operate the computers. So this is what the assessment looks like. It's comic book. And this was what I had to do. So I had to create an entire assessments. I was there for 3 cycles at Pearson, so I created multiple six modules or tasks, as you might want to say. And this is one task. I didn't create this task. This was a pilot task that was created for the program and then released so that teachers had something to do to study and show the students. And it has a full explanation of what this test is all about. So this assessment is one task, but it has multiple questions that are aligned to the next generation science standards, 3-dimensional item development for these students. And what's innovative about it is instead of having just a paragraph, blah, 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 the stimulus for these items are in comic book panel format. So we have story scene 1. I had to write these stories. I had to create the characters. I had to create the scenes. So my job was everything that you see that I'm going to show you, I had to create this. So I created this for 6 different task assessments. Students are supposed to be given 3 tasks when they take their state assessments in the spring, and they're given 3 of these tasks so that there's one for physical science, one for life science, and one for earth science. I was primarily assigned the physical science and earth science tasks to develop because of my physics background. I have a background in all relative science education scenarios: earth science, chemistry, biology, and physical science and physics. But primarily, I had about 20 years of experience teaching physics, about 6 years of earth science education classes, about 8 years of biology, about 4 years of chemistry. So I have a background in education out of my 25 years of teaching experience and all the subject matters that get tested. And I was a STEM teacher for 10 years also, computer programming and principles engineering, electricity, electronics, stuff like that. So back to this. So here is a panel, and there's another panel in the story, and this is a story scene. And then we have our simulation. So this is what the simulation looks like. And this is the paper version. So they just kind of answer the questions as if it was like a table format. Here we have questions. They have to decide A, B, C, over ABC for this. So now you see these are the three-dimensional next generation science standards question items that are implemented into it. All right, so we have different parts, different simulations. So this is available. This is on my LinkedIn page. It's also on the page that I just showed you. And let's just go through the actual computer-based portion of this. So this is what the actual real test looks like. You have the computer-based, and this is what it was designed for. It was designed for computer-based. So you can go to that website and then click on TestNav. It says you're a guest, and it explains there's going to be 7 questions, samples. It says welcome. You hit the next up here. It gives a video that explains how to use the simulations. And I had to create the tests also. So the entire cycle is from creative ideas at the beginning, how to implement multiple standards into one task, science standards, even mix of biology and physical science and earth space science in a single task if you can, even if it's just primarily based in one of those 3 subject matters. So these videos show students how to use the simulations that were created by the Concord Consortium in Massachusetts. You can go through this yourself and see these things. I know how to use it, so that's why I don't need to read it. All right, so you reach the end of the tutorial, and every task starts off the same way. So here we have Maya and her family member Samuel go to a tech museum. They're on electric scooters. And they want to see the electric scooter exhibit at the museum. And it looks like the Chicago Field Museum, if you ask me. But it could be the American Museum in New York City also. So my battery's 50%, mine is 25. I wonder why they're different. So they both were charged 100%. So this is our question, right? This is our probing question. She wants to know, why is mine 50% and yours only 25? Well, how are we going to do this? We go to the computer or the museum for this exhibit. It has a simulator, a computer simulator. So that leads us into what the science that's involved. And now we have our computer simulator. So what do we have here? We have these little gadgets. The mass of the person or student is either 40 pounds, 60 pounds, 80 pounds. The forward force is either 50 newtons, 100 newtons, or 150 newtons. And you go ahead and run that, and it will fill in our chart. It will show an animation here. We got a timer going over here. So we have our time in seconds and our speed, and we get our different answers. And then students can say, okay, well, this is what I got for 80 and 100. So now you can do a new simulation, and you can say, what about if it's a 40 that only has 100, or all the way to 150, and then hit start. And once again, we have our timer. So we're getting all this data. All right, so this simulation lets you use models. Your goal, use a simulation, observe what happens to the speed of each rider as the rider travels across screen. Change the mass and forward force settings for rider 2. So we have rider 2. And this is our data. So we did this. We already accomplished this just by playing around type of thing. Drag and drop the sentences into each let's see, drag and drop this sentence into each box in the table to describe the net force on rider 2 and the scooter for each situation. So we have the net force equals 0. Rider 2 is staying still. Rider 2 from 1 to 2 seconds. All right, so let's look at from 1 to 2 seconds. So from 1 to 2 seconds, we have an increase here in the speed. So he's staying still. The net force in the opposite direction. So the net force is equal to 0 if you're just sitting still, right? So we drag and drop that in there. The net force is in the opposite direction of the scooter's motion. The net force is in the same direction, right? So this is an increase in speed, or the velocity one direction type of thing. So we say, okay, these are good answers. And then we go on. So this is what a student would do. And they don't know what they had, but when they complete a section, in order to submit it, they have to make sure they get rid of all these orange dots here. So they go through, they read the directions, and then they use different. Oh, so this is nice. So I'm going to show you this one real quick. So here we go. We say, click here to learn how to use the simulation. Oh, let's click on there. Let's see what. Oh, look, it gives us basic informations on how to use A through E and all the rest of that. In the previous question, you observe how the speed of the rider change as they travel. The change shows one way the speed of each rider and scooter could change over time. So we have rider 1 and rider 2, and then speed over time. So the speed we saw increased over time for rider 1 in all our simulations. Your goal is to generate data that could be used to produce a version of the graph above in which the difference in the change speed of the two riders is the greatest. Use your settings for rider 2 to generate data for each new rider. So basically, we just want a greater speed for rider 2 than rider 1. So we're going to want him to be the least mass, or this student to have the least mass and the greatest force. So this is simulation 1. So we could see that this rider 2 has a greater increase than rider 3. So let's go to B. So let's do a heavy student with a heavier student with a lower force, and let's see what happens here. So rider 1 is moving faster than rider 2. Okay, and it's filling this in, it's giving us the data, so we see all that. It says the model that could be used to produce the graph above that shows the greatest difference in the change of speed in the two riders. Well, that's model A. So model A shows that kid going faster. Now, you could do this in any way. Now I could do 60 pounds with 150, and let's see if that gives us something. Well, these are really kind of more similar. So we would say, but I think that could be used since there's no numbers here. So this is D. So we have correct answers for model A or model D. The programming behind this, these could be in any order, A, B, C, or D, or E, but the data that's saved, you see this? The data that's saved as the students are moving in a specific time frame show which ones. So I could put D, and that's a correct answer. I could put A, that's a correct answer, but B is incorrect. And since I didn't do anything for C or E, those are also incorrect answers. And we have computer programming in here so that it knows which one of these options has the correct answers. All right. When the same net force is applied to two objects with different masses for the same amount of time, the object with the less mass experiences, and then this is just similar drop downs. So you can see that there's two ways this simulation is used in this assessment. It's used directly as the students creating data to answer a question and then realizing which one of their options that they created can be used as a correct answer and which ones are incorrect answers. And also general questions that after they run it, they just use common knowledge or knowledge from, they observe, scientifically observe, and data they collect and interpret to answer these questions here. All right, so and then you could do things, you can expand this so that's full size, you can expand it so that's full size. Students have those options. So then let's go down here. Here's more comic book style stimulus, which one of our diagrams best models a situation that would cause the scooter to slow down in the diagram. All right, so we would want a greater force against the student opposing motion to cause them to slow down. So these are typical questions that you would get from a typical stimulus, but it's in a comic book panel style format instead of just words in the stimulus. All right, more comic book panels, more questions on how to use the stimulus, how to get these, how to set it, speed of 10. So we have a speed of 10. Difference here is we got an incline, all right? Incline is 0. So let's see, we have incline of 0, which is flat, incline of 10%, which is large. And then what we're going to want to do is we're going to do speed of 10. Let's make the mass of the kid small. It doesn't tell you generate 3 models. So if this is the same, we got to just change the mass. So we're changing one variable. So this is you change in an experiment, you change one variable at a time. So we run that, and then we pick a new scenario. Okay, that's 60. We want this to be 0 and this to be 10, and we change that. And then we pick a new scenario, and this student has a mass. So this is 0, and this is 10. We run that. And when that's completed, we're going to want to create graph points here, create a graph. So we got 3 points of data. We got the mass of the student. So we have the mass of the student is 40. And the kinetic energy we have to determine, don't we? Mass times velocity squared. So we have the speed, and we have the, oh, here we go, kinetic energy. It's given to us. Sorry. And here's the battery levels too. So here's the data. So remember, this was our driving question at the beginning of it. Get it, driving? That why is the battery energy lower for the adult than it was for the young student? Because the adult weighs more. See, they're supposed to interpret this now. So we have our speed at 40. The speed is 10, and it's a constant speed, and it's 320 all the way across. So let's take our first point and put 40, 320. And then we have a mass of 60. Oh, wait, I'm sorry, I got this wrong. So this is where the mass is 40, all right? When the mass is 40, I got to click on these because it's different data. When the mass is 40, it's 160. So when the mass is 40, it's 160. When the mass is 60, it's 240. And then we had over here, I think 320, right? Oh, yeah, 320. So it's 80, it's 320. So all this data, can I get in 160, 240, and 320 is all in these little bars too. So we have, move this over from 80 to 320. So we have a nice straight line here. And that's all the student had to do is create that graph line. So that's really good. And then you see we have more interactions. We have the directions, what they should do, and then which model they need to pick is correlated to the correct answers. And then this is a data point that they find by completing the assignment or the item. Same thing here. We pick the models, A, B, C, or D after we make them. More questions, and then this is the ending. So this is our constructive. So now the students are supposed to identify one form of energy the battery's chemical potential energy was converted into when Maya rode her scooter to the tech museum. Explain how you know that energy is conversion. So these are not currently corrected by the computer programs. These constructed response are hand scored by volunteers or paid volunteers, teachers, educators, whoever they want to hand score it. So the information when the students signed in, they had their own identifying information, and then these are hand scored. And then that is added to the computer scores for the student's final score on what this test is. Let's see. Identify one form of energy the battery's chemical potential was converted into. So we could say kinetic energy. Because it began moving and lost some of the battery's chemical potential. All right, so that's one answer. Obviously, you could have said gravitational potential energy because it's going up an incline. So as it goes up an incline, actually, no, the gravitational potential energy. Well, yeah, because you'll roll back downwards. So you could say gravitational potential energy. It's all about what your explanation is for these different energies. And then explain why the battery of Sam's scooter had less energy than the battery of Maya's scooter. So that's something we had from the beginning. It's because Samuel was heavier than Maya. And then part C, after Tech Museum, Maya and Samuel plan to go either library or store. A table shows distance inclined, blah, blah, blah. Identify whether Samuel would be more likely to reach the library or the store without using all the charge in the battery explained. So this is all culminating. They have to use all their information to figure out what the answer to this one is. And then that's it. Submit your final answers. It tells you that these ones have not been answered. All right. So you have to go back and answer them. You just go ahead and click on it. And the other ones had. So you're not supposed to submit your answers until everything's, because unsubmitted answers are incorrect. And that is what I was creating at Pearson when I worked on the Massachusetts Innovative Science Assessment Project. You could try this out yourself. Once again, you can go to that website. You could just click on any of these. There's a 5th grade one. They got the paper version. You could use text to speech, all that. And then they have, let's see, the computer-based one from the previous year. Let's see what that one is. I worked on both 5th grade and 8th grade. Boop, 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 boop. Oh, this one's nice. It's about field mice and stuff. And you could try out the different simulations, different science simulations to see what they did. All right. So it gives you a percentage here of these different ones, and then you have to figure out all the genetics behind it for all the questions. So go ahead, try these out yourself. I hope you enjoyed this innovative approach to assessing student learning. I enjoyed working on this project so much because I was able to use creativity to create stories, to my artistic graphic design skills, to design simulations, to develop simulations with the Concord Consortium. So I would suggest what a simulation should be. I would draw designs of the simulation, and I would work with the Concord Consortium that they implemented a simulation that was accessible to all students, UDI.